You'll see that like I probably won't write a ton on here because most of what you guys have is on the board itself. All right, so look at number 1. So Liam did number 1 for us. All right, so it has you guys fill in the blank with the definition of midpoint. It's a good definition for you guys to know, okay? So Liam, we just had to do like the equation part of it, right? So what'd you write?
I wrote AB equals AM plus MB.
Yeah, so M is the midpoint of AB, so then AB is going to be equal to AM plus MB. Good. All right, cool. All right, and then let's do segment addition postulate. So nobody did that one, but it's one that we use pretty often. Angeline's going to help us out, though. So if point E is between D and F, not necessarily in the middle, just has to be somewhere in between the two, then what can we say, Angeline?
DE plus EF equals DF.
Good. DE.
Also for number 1, could you also say AM equals MB?
Yeah, I don't know why I did that, actually. Equals DF. Let's try that again. So for number 1, it shouldn't say this at all. It should just say AM equals MB. So, yeah. Should just say AM equals MB. Should not say that. Thanks, Angeline, for correcting that. I appreciate you doing that. Yeah, definition of midpoint is just two things equal to each other. When we use segment addition postulate, those would be two things added together equal to one thing. So we have to fix that. Okay. All right. So let's look at some of our properties. We wrote these on the side over here. First one was definition of congruent segments. So we talked about how to use this one. Who did number 3 for us? Kyle. All right, Kyle. When we use definition of congruent segments, what are we doing? You wrote PQ is congruent to QR, right? What I do need to add to yours is pretty good, but what I do need to add is, yeah, the squiggly, right? But basically, when we use definition of congruent segments, we're just changing our notation, right? So like if you look in the problem for number 3 on the board, it's got it, no segment lines above it. This just represents a numerical value, but we want it as something that would be a geometric definition. So we would put the segment marks above it and then the congruent symbol between the two instead of equals. All right, subtraction properties. So it says if AB equals CD and EF equals CD, then what can we say? Who did number 4? What'd you say, Alyssa? Good. AB is just going to be equal to EF. What did you subtract from both sides? Good. CD was repeated on both sides, so we can subtract it and get rid of it. So that's what we have. Okay, very good. All right, substitution property. That means we need to take something out, put something else in. If MN equals NO plus OP and NO equals EF, then what can we say as a result of that? Who did number 5 for us? Also, Alyssa. All right, Alyssa, what'd you say? Good. MN equals EF plus OP. All you did was you took out NO and then you substituted in its place EF. Very good. Liam, what's up?
Are there any questions like 1 through 5 on the quiz?
Definitely fair game. Yep, absolutely. I would say there's a good chance of that. Honestly, this sheet that I gave you guys here looks pretty similar to your quiz. Like the type of stuff you guys see on here. This would be a great thing to study from this weekend. That's why I'm making the key, and then I'll post the key for you guys as well too. But it'd be a great thing for you to study from this weekend, as well as the practice quiz that we're going to do here in a few. All right, name the definition, property, postulate, or theorem that justifies each one of our statements. Okay, so number 6, it says if angle ABC equals angle or is congruent to angle DEF, then the measure of angle ABC is equal to the measure of angle DEF. This one's a little tricky, but it's not going to be segment addition postulate for a couple reasons. It's talking about angles, not segments. Tegan, what do you think? Yeah, it's definition of congruent angles. Liam, is that what you were going to say?
Yeah.
It changes your notation from congruence to, they put an M, which indicates a number, and an equal sign instead, okay? When we talk about like physical pieces, whether it's like a physical angle or a piece of a segment that we don't really think about the number of, that's when we use this notation on the left with the congruent symbol. But if I talk about something that represents the measure of it or the length of it, then we use equal signs because we're thinking about a number. So we would say definition of congruent angles. You can tell I like that calligraphic pen that I found yesterday. All right, if AB equals GH and GH equals MN, then AB equals MN. Kyle, was that you?
Yeah.
What'd you say it was?
Transitive.
You said it correctly. So this would be the transitive property. Very good. All right, cool. And then 8, it says if XYZ is a right angle, then the measure of angle XYZ is equal to 90 degrees. This one's a little tricky. I know that no one put it up there. Does anybody have an answer for this one? We'll see whether it's right or not. What do you think, Julia?
Definition of a right angle.
That's perfect. I mean, that's by definition, so I would say definition of right angle. Good. Definition of right angle is exactly right. Very good. Okay. All right, if the measure of angle 7 equals the measure of angle 8, then the measure of angle 8 equals the measure of angle 7. What'd you get, Chris?
Symmetric.
Symmetric property. Good. And you smelled it right. Good job. Mine looks a little weird up there, but symmetric property. Very good. All right, now we get into the proofs. Okay? Now, proofs like number 10. Proofs like number 10, fair game. You could see something like number 10. Also, Caden, do you have your sheet out? Dude, what planet are you living on right now? It's not in this class. Give yourself at least a chance to do well at this, okay? All right. Something like 10 is fair game, or like something like 11, fair game. But don't forget, I didn't put one like this on there. Don't forget that we did algebraic proofs as well too. So remember that was when you were just solving for x. You guys did really well with those. So it was just addition, subtraction, multiplication, division, distributive property, substitution, that type of stuff. You could definitely see one of those as well too. Okay. All right. So let's look at the proof for number 10. Probner, you did this one for us. You started by doing what?
Writing the equation down.
Writing the givens down, right? So I know that AB is congruent to AC. And I know that PC is congruent to QB. We want to prove that AP is congruent to AQ, okay? So then it looks like after that you subtracted something from both sides?
I don't even know what I did.
Okay. All right, well, let's start the same way he did. I'm going to try to write this small, but we'll see how that goes. All right, so statements, reasons. Okay. All right, so the first thing we want to do is list our givens. You can either do it as 2 steps or as 1 step, whatever. I usually like doing it as 2, but it doesn't really matter. So AB congruent to AC. And then second step, I should do it as, oh well, it doesn't matter. PC is congruent to QB. Shh. All right, the reason for both of those is given. So I'm just going to write a really big given, okay? All right, so now let's take a look at what we want to prove. So I know that AB, the whole segment, is congruent to AC. So those two big segments are congruent to each other. Eventually, I want to get to say that AP, the little guys at the bottom, like towards the vertex of that triangle, the little guys at the bottom are congruent to each other, okay? But I know that the whole big segments are congruent to each other. And then I also know that PC, this part, is congruent to BQ, or QB, okay? All right, so I stated those in there. So here's what I'm thinking. If I want to show that like two big segments, or I know the two big segments are equal, I want to show smaller segments are equal, I'm thinking I'm probably going to have to break this up. Would you agree? Like break it up into smaller parts? Okay. So if I do that, that would dive us into using what postulate next? If I want to break up a big segment into smaller pieces. No, you're right. Cool. Yeah, I think we're going to use segment addition postulate, right? What does that look like if I want to use segment addition postulate on the left side? I'm going to do it for both, but if I want to do it on the left side, what would I write? It was number 2. What did we write for number 2? When we had a point in between two segments, what did we write? Oh boy. All right, let's go back to number 2. Yeah, so like segment addition postulate, we would have two smaller segments equal a larger segment. So we added two segments together to equal a larger one, right? So if I do that for number 3, or for my third step, let's say I do it for AC, okay? So AC would be equal to what? AB, AP plus PC, right? So AP plus PC. And then I'm going to keep this in the same step because I'm going to do the same thing just with the other side. I could do it with AB, right? AB would be equal to what? AQ plus QB. Okay? And then my reason for that would be segment addition postulate. Okay? All right. Well, what did I know about AC and AB? I know that AC and AB are congruent to each other, right? So I can set these two pieces equal to each other. Okay? So then I'm going to say that AP plus PC equals AQ plus QB. Okay? So what I did was I took step 3 and I substituted it into my original statement. Okay? But instead of doing it like just the two letters, I did the two things added together. Okay? Now, I wanted to get to the point where I have AP is congruent to AQ. That's my proof statement. I have AP here and I have AQ there. So I'm close, but what do I need to get rid of? PC and QB. What do you know about PC and QB? They're equal to each other. So here's what we could do. Since I know they're equal, I can substitute in one for the other, and then I would have both of them on either side of the equal sign, and then I can subtract them out after that using subtraction property. Okay? So here's what I would do. I would say, let's substitute in PC for QB. Okay, so I'm going to put PC in where it says QB right there. So then I would say, but this is, what property would we use for number 4, by the way? Substitution, good. Problem, did you do that? I see substitution property, or was that subtraction?
I said substitution.
No, that's subtraction.
Oh, how do you know that?
Brother, that's subtraction. That's subtraction for sure. All right, well, either way, AP plus PC equals AQ plus, we said PC and QB are the same thing, so I'm going to write PC again. That's also going to be what? Substitution. And then, what do I have on, oh man, I can't write on that gray bar there. What do I have on both sides? A PC that I can get rid of. So then I can say that AP is equal to AQ, which is what I wanted to prove, right? That's what I wanted to prove. Now, what reason would that be? Subtraction property. I need to be writing property after each one of these. It's a bad Mr. Pacifico. Property. Okay. All right. So that's what we had to do for 6. Something along the lines of that. Okay. All right. Let's look at number 11. Ryan, you did number 11 for us? Yes. Okay. So we've got C is the midpoint of BD and D is the midpoint of CE. We want to prove that BE or BD is congruent to CE. So Ryan's proof is behind you guys. If you turn around and look at the board back there, Ryan's proof is back there. Okay. Now, if you know that C is the midpoint of BD, what did you say after that, Ryan? If you know that C is the midpoint of BD, what did you say after that? Well, let's look at what your work is. You wrote your givens already, and then after your givens, what did you state?
Number 3?
Yeah.
Oh, BC equals CE.
Okay, so BC is equal to CD because of...
The definition of midpoint.
Yep. And then you said basically the same thing for step 4 as well too, right? So I know that CD and DE are equal to each other. All right, super. So then that's definition of midpoint. And then after that, you knew you wanted to prove like bigger segments. And you had a bunch of small segments that were equal. So then you like broke up those bigger segments using what?
The segment addition postulate.
Segment addition postulate. Okay. So then you said BD equals BC plus CD and CE equals CD plus DE. Okay, that looks good. Now, before we launch into saying BD is equal to CE, there's a couple things that we have to do. So, I'll write it up here. Ryan got us like 75% of the way there.
75.
Well, no, we're shooting for hundreds, man. What are we doing here? We're not settling for mediocrity. All right, C is midpoint of BD given. And then my second given is D is midpoint of CE. That's my second given. And then after that, I like what Ryan did. He said BC is congruent to CD. Definition of midpoint. And then 4, I don't have to do a separate statement, but I'll do it anyways. CD is congruent to DE. And then again, definition of midpoint. Okay, so I have that those small segments are equal to each other. So then now, what Ryan does after that is he uses segment addition postulate to like break things up. Okay, turns into like a long proof. So then you said that BD is equal to BC plus CD. And then you also said that CE is equal to CD plus DE. Okay, we're almost there. So 5 and 6 were segment addition postulate. Okay, so now we're caught up with where Ryan was. Okay, so now what I want to do is I need to somehow show that BD is equal to CE. Okay, well, I know that BC plus CD equals BD, and I know that CD plus DE equals CE. What's repeated between these two statements right here? CD, right? So what I could do is, since I know that BC, so I got to use that somehow, the fact that CD is repeated, okay? Well, because of that, I also could say that I know BC is congruent to CD and CD is congruent to DE. So is it fair for me to say that BC is equal, or is congruent to rather DE? So if I know that BC is congruent to CD, but I know CD is congruent to DE, I can say that BC and DE are congruent, right? What property would that use? So if I know that BC is congruent to CD, but CD is congruent to DE, I could say BC and DE are congruent. What property does that use? Transitive. You could use transitive. I'd probably be lenient, let you use substitution as well too, but we could use transitive property. So transitive property. Okay, almost there. All right, step 8. That's close to what I want. I want BC plus CD equals DE plus CD, or CD plus DE. So what I could do is I could add CD to both sides of that equal sign. So if I do BC plus CD equals DE plus CD, I'm adding CD to both sides. Do you guys agree? So then that's addition property. I have one more step. This one turned into a long one. There's probably a faster way I can do this one, honestly. But I have one more step. Tegan?
Let's just go as, couldn't you go straight from like 3 and 4 to 7?
You could, because then you'd be adding, because then that would be transitive property, right? So then here's where you would get to, okay? You would get to from 7 to 8, right, by adding CD to both sides. And then from there, you would have to show that BC plus CD equals BD. So you'd have to go back and show step 5. And then you could say that DE plus CD equals CE, and you'd have to show step 6. So it wouldn't save you because you'd still have to do it. But your last step here is to say that, okay, I know BC plus CD is BD from step 5. So BD is equal to, and then I know DE plus CD is CE, which is what I wanted to prove. And then that is going to be substitution. I don't think there is a faster way to do it. You might be able to save on the numbering by combining some steps together, but you would have to say all of that, okay? That's a long proof. That one's tough, okay? That's a hard one.
Are you gonna give us one like that on the quiz?
I don't want to rule anything out. So I don't want to say necessarily yes or no. But, you know, I also could give you something like that and give you like the statements already there and you have to put the reasons in. That's also possible. We'll see some of those problems in your homework tonight. Okay. All right. Let's talk about angles real quick. So let's talk about these. Since I didn't assign them, I do want to go through them with you guys though, just to give you an idea. Okay. You guys remember like vertical, adjacent, opposite rays, complementary, supplementary, linear pair, that type of stuff. Okay. All right. So for 12 through 14, we're going to use the one that's like up at the top of the screen there. Which angle is a linear pair with angle 7? 6. And what else? What would be another linear, what other angle would form a linear pair with angle 7? 8. So you could say angle 6 or angle 8. I said and, but or would have been the better word to use there. What angle is vertical to angle 7?
9.
Angle 9. Okay. Don't just put a number. Make sure you put an angle symbol. Name an angle that's adjacent to angle 3. You got 2 options. What'd you say, Haya? Angle 2 would work. You could also say angle 4. Either one of those would be good. Okay. All right. Let's do the figure at the right here for these. What are the sides of angle 2? Your sides are what geometric figure? It's a ray. So then how would I name the rays for angle 2?
PC and PB.
PC and PB. Good. So I'd say PC, ray symbol above it, PB. Wow, that's a crazy looking B with a ray symbol above it. What would be a pair of opposite rays here? So it'd be rays that form a straight line when you connect them. PA and PB, good. Okay. All right, good. Why are you not writing this down? All right, what's a pair of congruent angles? They don't give you any angle measures in here. You would just have to pick out a pair of congruent angles from this picture.
Angle 1 and angle 3.
1 and 3 would work. What else? Your other pair would be what? Not 5 and 6.
5 and 4.
5 and 4, which is what I think you meant. So angle 1 and angle 3, angle 5, and angle 6. All right, what about, what's the vertex of angle 3? Point P. Yep.
Number 6.
Did I? I did write 6. Darn it. Let me fix that. What did we say? 5 and 4. Okay, and then point P. Max, what are you doing? Do you need this worksheet? You have this worksheet? Didn't I give it to you? Okay, all right. And then draw a diagram that represents CD bisecting ECF. So you can draw this a bunch of different ways. We could say this is E, C, F, and then CD would have to be a point in between, and you'd have to know that those angles were congruent to each other. Okay, all right. Questions on any of the other stuff that we did on there? All right, let me give you a practice quiz. We'll do a couple of this stuff together. We've got about 18 minutes to do this, and then I'll give you guys another worksheet. All right, so between what we just went over and this practice quiz that I'm giving you is 2 pages.
Darn it.
No.
I got 2.
Nothing against you, Pradnor. I just we're reviewing stuff.
I need you. I need you.
I'll pass out a stapler. You guys should use a stapler. All right.
Give me the eraser as well.
Where's my stapler? Right here.
You should have been paying attention. You were my manager. You were my broker manager.
2 pages. 2 pages. 2 pages. Oh man, you got messed up.
Appreciate it.
Everyone got 2 pages?
Yup.
I got 3.
Okay.
You guys need to see.
Okay. All right. I don't think I put this one on Progress Book, but or not on Progress, but Google Classroom. But maybe I'll just make the key and put it on Google Classroom. Okay. So what I want to do is I want to go through this. We're not going to go through everything, but I just want to hit some highlights of this one. But there's a lot of good stuff on here. The first part has you guys draw and label like each one of those. So this is vocab from your test. Okay. But as I'm grading the test, I thought it'd probably be a good idea for us to review this as well too. Hopefully I get this test graded this weekend. I spent 3 hours grading my honors pre-calc test last night. So hopefully I get to yours this weekend then, because now yours are the next up. So, all right. So draw those angle relationships, any one of those. I mean, we've talked about how to do some of those. We did those on the board. But I kind of want to scan through here and prioritize what we want to do here. Okay. Naming angle bisector, congruent angles, sides, that's all good stuff as well too. But maybe we'll talk about properties and then focus on like one of the proofs. So let's do these properties together. Okay, let's roll through these because I think we can go through these pretty quick. Number three. All right. What property are we using for number 3? What do you think? You said what? Not transitive. Not definition. What did we have when it was something was congruent to itself? Same thing on both sides. I heard it. What is it, Braden? Reflexive property. Reflexive property. Why is it writing so thin now? All right. Okay, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Chris, which one is that? Nope. There it is. I came to you because it's the one that you did earlier. All right. So symmetric property. All right. If the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 minus the measure of angle 3 equals the measure of angle 2 minus the measure of angle 3. Which one is that going to be? Not substitution. You said what? Not transitive. Let's look at what we got. We started with measure of angle 1 equals measure of angle 2. And then we have that again, measure of angle 1, but now it's minus measure of angle 3 equals measure of angle 2 minus measure of angle 3. What do we do to both sides? We're subtracting the measure of angle 3 from both sides. So it's going to be subtraction property. Yeah. Okay. If 7x equals 35, then x equals 5. Division. It's division property. All right, good. All right, measure of angle 1 equals measure of angle 2. Then angle 1 is congruent to angle 2. Close. We're not talking about segments there. Angles. We would do definition of congruent angles. Good spot. Definition of congruent angles. All right. If A equals 5 and B equals 5, then A equals B. Could use transitive. What other one? Substitution. Either one of those would be perfectly fine. I'm going to say substitution. Anytime we substitute a numerical value for letters, substitution is a good way to go. If point B is the midpoint of AC, then AB is equal to BC. Angeline, which one's that? Close. It's a definition, though.
Definition of, midpoint.
Midpoint. Definition of midpoint. It woke Liam up out of whatever he was doing, though, that's for sure. If A equals B and B equals C, then A equals C. Tegan. T for transitive, yep. All right, cool. I wanted to roll through those quick. All right, let's do the proofs that are on here. Okay, just more segment proofs. We've just been pounding away at them. All right, PQ, given PQ equals RS, we're going to prove that PR is equal to QS. This is another very similar segment proof that we've done a couple times before, okay? So try it out, statements and reasons. Poor Kyle. What's the first thing we write? It's a good thing they got these like really nice cases for you guys, because the number of iPads that I see fall during a day. My iPad at home that like my daughters use is like got like the nicest case on it, because like I knew for a fact I think they drop it less than any, I don't know, than any one given class period. There's always at least one iPad that drops. Okay. So I know that PQ is equal to RS. I want to prove that the bigger segments, PR, is equal to QS. So I'm not going to use like definition of midpoint or anything like that. They didn't tell me that as a given or anything. What should I use here at some point? Probably segment addition postulate, right?
Yeah.
Okay. Well, let's just dive right into doing that, because I'm not really sure what else we would do. Okay, so then what segment am I going to break up? PR, and what else? QS. Let's just do that in one step. So PR is equal to what?
QS.
No. Not yet. We gotta get there. PQ plus QR. And then the other one would be QS is equal to what? QR plus RS. Yep. And then we said that was what? Segment addition postulate. You guys okay if I write SAP? You guys, we all know what that means?
Yeah, I'm fine.
All right, you're fine. Great. Okay. Well, I know that PQ is equal to RS, so I can substitute those in any cases. But the other thing I can do is, like I have, okay, PQ is here, RS is there. What else is in those pieces that I just made? QR is in both of them, right? So they both have QR, okay? But what do I know about PQ and RS? They're equal, right? So what I could do is I could take this statement where they're equal to each other, and what could I add to it? You just put it on my desk. Thanks, Tom. Does anybody else need a stapler? We good? What could I add to it? QR. So I'm going to do PQ plus QR equals RS plus QR. What reason would that be? Addition. All right. Okay, well, what is PQ plus QR? PR, right? What is QR plus RS? QS. So that's how I can say that PR is equal to QS. And the reason for that would be what? No, not a definition. Shoot. Substitution. That's what we want to use it for that one. Because we substituted in PR for PQ plus QR right there. And then same thing with QS. So substitution property. Okay, that went better, for sure. Now that we've practiced this a couple of times, I feel as if that went better. Okay. All right, let's do a midpoint one. So write our statements and reasons. I'll make this a little bolder. All right. First things first, what do I want to list? My given G is midpoint of FH. Sometimes you guys get to where you write your given and you just don't know where to go from there. That's very common for every geometry class I've ever taught. That's a very common thing, okay? And the last problem, I couldn't really use my given. Like they said that those small segments were congruent to each other, but I couldn't do anything with that. Like I had to use the picture in the last problem. However, since they gave me a vocab word here, I can use the definition of that vocab word to help me out. I know that something is the midpoint, so what does that tell me? When I say midpoint, you guys say two congruent parts. What are my congruent parts? So let's state that in my proof. FG is congruent to GH. Now notice in the last one, I didn't do any like definition of congruent segments. I didn't change my notation at all. I just use equal sign all the way through. But since I'm using the definition of the midpoint, I should use my congruent symbols and my my segment marks up above. What's my reason for that? Definition midpoint. Okay, so def. I'll write it out. Stop being lazy, Mr. P. Of midpoint. I didn't write midpoint out. Never mind. Okay. All right, I marked it in the picture. Now I want to show that 2 times FG is equal to FH. T, what do you got for me?
Curious if we can short midpoint to just MT PT. Would we be able to do that?
You want to take the letter I out of there? Is that what you're saying?
Basically.
I guess. I would rather it be mid PT. I don't know why I'm drawing the line at the letter I, but I don't know. I just would rather you write midpoint, even if it's just mid PT. I don't know. Okay. Where should I go after that in my proof? I know that those two small segments are congruent to each other. I want to show that 2 times FG, 2 times the little guy is equal to the big guy. What do you think I should do from there? Add what? What'd you say?
Add FG plus GH equal FH and use segment addition postulate.
I like it. Julia wants to use segment addition postulate. Let's do that. FH, I'm going to do it in a slightly different order than you did, but that's equal to FG plus GH. Great. We know to do that because we want to work with the bigger segment, okay? So let's break it up. And she said that was segment addition postulate. All right, so then now, we're almost there. I have FH equals FG plus GH, but I want FH equals 2FG. Hiya?
I did FG plus FG equals FH and I did substitution.
I like that. So FH is equal to, I'm sorry, should be congruent. You said FG plus FG?
Yeah.
I like that. Substitution property? Okay. Now, I'm going to do this before I do my last statement, which you can clearly see where that's going. You see how I've been using segment marks and then the congruent symbol? I'm going to switch notation now. If you don't do this on a fully written proof out tomorrow, Monday, I won't take off points. But remember, if you have a proof where it's like fill in the blank, just be cognizant of the fact that you might have to use definition of congruent segment. So the next thing I'm going to write is going to look exactly the same, but just without the segment mark above it. So FH equals FG plus FG. And I should have done it earlier, honestly. definition of congruent segments. Hiya, what's my last step going to be?
I did 2FG equals FH equals substitution.
Good. So 2FG equals FH or FH equals 2FG. And then the reason for that again is also substitution. Okay. All right. I'm going to give you guys an additional worksheet for this weekend to help you practice. And then, this is only one page though. And then it's got some of those algebra proofs on there, and I wanted you guys to practice with those. And then some other like fill in the blank proofs. So do these. We'll come back on Monday. We'll review a scant amount, and then you guys will take your quiz.
Didn't do anything, bro.
Not the Turkish shower. Shower?
Shower? Are these two? Oh,
Just one, thank you. You guys had enough.
no.